Good day, everyone. Thank you for joining today's webinar. My name is Roberto Campetti. I'm the Regional Product Manager for GIS ADMS. Today, we'll be discussing delivering a single source of truth through network-based GIS to ADMS integration. Reasons for integrating a utility's GIS to the ADMS are becoming more a necessity than a nice-to-have, especially given the growing need to view and operate from a geographic diagram, low-voltage networks, and as an enabler for DER orchestration. Joining me today is one of my GE colleagues, Jennifer Reeves. Jennifer is our Global Product Manager for Electric Office GIS and the GIS Adapter solution, which is a key part of today's discussion. Along with Jennifer and myself, I'm delighted to have two guest speakers, Matthew from Top Energy and David Beasley from Energy Queensland. Both are GE customers currently undergoing GIS to ADMS integration projects. This webinar is part of a series of GE ADMS webinars. And if you're new to the series, you can still get access to the previous webinars via links on our webpage or contact me directly via email. Also, throughout this webinar, you'll be able to log questions using the tool, and we'll aim to cover as many of these questions at the end of the session. Great, let's make a start. There's no doubt it's getting harder and more complex to manage the network data, network model, and the accuracy of both. At GE, we're working with customers on the journey to ultimately attain network level optimization. So even with the grid getting more complex, we are delivering solutions which not only provide a point-to-point integration from one operational system to another, but which connect and orchestrate across a growing footprint of both utility and non-utility owned assets. One of the underpinning fundamentals in this journey is having accurate and consistent data models and the ability to maintain and update this data in a timely and cost-effective manner. An example of a data model is the network model, often represented and maintained differently in the utilities GIS and ADMS. At GE, we go beyond just the point-to-point integration and can provide native interoperability, enabling the utility to improve data governance and simplify data maintenance across the GIS and ADMS. At this point, I will introduce Jennifer. I will hand over to her and she'll talk us through GE's network model management solutions we have today. Over to you, Jennifer.
Thanks, Robert. Good day, everyone, and thank you for joining us. So today's grid management relies heavily on a lot of different informational and operational technologies and tools, and those tend to be siloed systems, including SCADA, AMI, DERM, ADMS, and GIS, to name just a few. And network designers and mapping departments are using the GIS to plan and update the normal state of the network in one silo, and control room operators monitor the real-time state of the network in another silo. And then you have the OT support teams needing to continuously maintain the disparate representations of the electric grid. So this current mode of operation can lead to data issues, and network documentation can be incomplete or lack data integrity and can be electrically invalid. So for many utilities, their electronic map data was historically created with little or no quality rules, controls, or standards, and tended to be more of a visual representation of the network rather than a connected network of assets. And the practice of working in the different silos across the enterprise has resulted in redundant and inconsistent views of that network data and variable ways to address the same problem between regions and departments in different ways. Duplicate data capture with no common foundational view is a very inefficient way to operate, and inevitably leads to data errors, omissions, and most detrimentally, potential safety issues for the workers in the field. So with the growing complexity of the distributed energy resources and renewables and the accelerated pace of grid modernization today, all utility companies must get a handle on these challenges. So GE's Smallworld Electric Office is an industry-leading network-based GIS that incorporates workflow and data quality management throughout that planning, design, and build stages of the asset lifecycle, and coupled with the ability to share a consistent, validated view of the as-built network for use by your ADMS to operate and control the network, can reduce integration costs up to 30% and reduce data synchronization errors up to 50%. So Electric Office models all voltage levels and full connectivity topology by phase for generation, transmission, distribution, and distributed energy resources, both renewable resources and storage. So through a workflow-driven approach, data governance is enforced and data quality assurance is built into the process so that the data can be shared and visible across the enterprise for all types of users, whether they're in the back office or in the control room or out in the field. GE's Smallworld GIS adapter provides a workflow-driven, service-oriented, SIM standards-based integration between GIS and ADMS, or even potentially other operational systems to share that network model. The monitoring and logging mechanisms enable control and auditability of that process, and network model exchange is controlled via the orchestration workflows for circuit-level initial load, as-built updates, proposed changes, as well as circuit resynchronization and republish capability. GIS Adapter enables you to share a consistent view of the network model and reduce redundant data entry to continuously improve the network model data over time. And an integrated solution of the network-based GIS and ADMS with a shared, consistent view of the network model builds a strong foundation for evolving with the rapidly changing landscape of the electric industry. And when this solution is provided by a single vendor, you realize the additional benefits that can save your company millions of dollars over the life of the solution with improved business process efficiency and workflow-driven data quality and governance, and your total reducing your total cost of ownership for that end-to-end GE solution can provide real cost savings. So Robert's going to talk us through the process at a high level.
Yes, great. Thank you, Jennifer. Great insight into what a GIS adapter can provide customers. I thought I'd add to that briefly by covering an overview of a typical process followed when integrating the GIS to ADMS. This slide summarizes 5 key steps in the process. These are integration planning, preparation, pilot load, initial or bulk load, and validation. It goes without saying, fail to plan is planning to fail. So the first step is all about planning and discovery. 2 items of particular importance in this section are the GIS data readiness, meaning understanding the level of data quality, electrical connectivity, asset details, etc. This sets the scene for the overall complexity of integration. Of equal importance is the business process changes required around data maintenance and keeping the GIS updated for an as-operated model. The preparation phase is all about getting commonality across the 2 systems, mapping rules, asset IDs, symbology. Time spent here is worth its weight in gold later on. Pilot loading, this is where we put our planning and preparation phases to the test and ensure we're getting the expected results in the ADMS. Generally, there are a few iterations of this phase, but once the pilot load proves successful, the initial load or bulk load can begin. This involves loading a circuit at a time until all the required circuits are loaded into the ADMS. It's important to do some level of validation at this point to catch any big errors or data inconsistencies early. Now, depending on the size of the network being loaded, the final validation stage can either occur after the circuits are loaded or kicked off in parallel with the bulk load. Finally, once utility is content with the results of the circuits being loaded or the entire load has been completed, the incremental updates from the GIS to ADMS can be enabled.
Energy Queensland, that's where we're sitting in our little part of the world. We are the result of a merger between Ergon Energy and Energex back in 2017. We have a fairly large land area and a lot of lines, but when it comes to comparing our customers for our area, it might be considered a low customer density. We do have a fairly significant solar PV on the rooftop uptake, but probably a key notable thing for us is that the distance between 2 of our network operation centres are going to be nearly 1,400 kilometres apart, and it's nearly as far as Melbourne or Auckland, so we do have a bit of tyranny of distance. Sorry, the slides didn't progress. There we go. So Southeast Queensland went live on Power On in 2014. They're currently running ADMS Series 5.22, and we're upgrading to Series 6 at the end of this month. So we got CAB approval a couple of days ago. We're also doing an asset infrastructure renewal in 2019, and this will include our servers, operating systems, databases, middleware. And one of the constraints that we always have with our projects is our storm season, going from November to April. So we try not to do any work on the system during that time. The overview that you see there, we have a pretty substantial amount of integration to our DMS, and we leverage that pretty heavily. The UDMS project itself is going to implement a DMS capability for our north-south regions. It will replace the legacy SCADA system and their paper pin boards. The configuration will be based on the southeast solution, and we are going to have a interim state where we're going to be using an internal and an external OMS for the different regions, just as part of our transition state. We had to run a proof of concept to confirm that that would work, and that went quite smoothly. Nice things like the LV network and some ADMS features like FDIR are out of scope. We have aspirations to get them in, but it just won't be within this project. Now, the data migration. So we have run our proof of concept, and we found lots of work that has to be done, but there are no showstoppers at this stage. We're going to use the GIS adapter from Smallworld, and we're going to land the DMS data in a geo format, and then we'll use the DSM tool to schematize it back into the DMS. So that's the second step that Roberto was showing before. We did have some concerns around the bulk load impacting the performance of the production system. We also ran a proof of concept on this using a build server with one-way replication so that we can load everything. We can load the sim, we can export it to the DSM tool and then load it back in and not impact the production system. The go live is planned to be incremental. We have 6 regions in our north-south area of the state, and at this stage we're probably going to go one region at a time, but it'll be even when we say regions, it'll probably still be cut over feeder by feeder or sub by sub. At the end of that, we would do a big bang go live with the OMS in the north-south. So the challenges that we found is largely around data quality. Things like dropout fuses were always known, so we never modeled them in the GIS, but all of a sudden they're important to the DMS. Things like circuit breakers, reclosers were all modeled as a generic switch, and suddenly we want to know what they are because that impacts switching sheet steps. The fact that most things were manual, there was incorrect connections. We also would place placeholder components. So if there was an RMU, we would put a generic RMU in there, and then with the intention of going back and fixing it. And over time, we have fixed some of them, but there's still generic components in place. Lots of naming or numbering corrections because we've come from 6 electricity boards. They've all had their own standards and procedures. And then schematic errors and topology errors. So we do have some challenges in the data space. None of it's insurmountable. It's just the time and effort that we have to go through and resolve that. The big benefit we're expecting from using SIM is that we can do incremental updates to continue to fix our data in the GIS instead of having to fix it in multiple systems. And whilst it's not in this project, we are also expecting importing the LV will be much simpler, primarily because we don't need to schematise it, which means we can reload it if and when we want to. So that's one of our big benefits that we see going into the future.
We're just a small utility, top end of New Zealand, reasonably narrow. Tasman Ocean on one side and the Pacific on the other. We get quite hammered by a lot of storm systems. So we've got our numbers there. We have 32,000 ICPs, 430 SADI minutes a year, so we are a fault-prone network. So that's just how we got to where we are. So the ADMS project for a Series 6 ADMS was approved by my board back in late 2017. The project went live, started go live in 2018, and we're building away furiously at the moment. The business case was purely on a safety and risk minimisation. I've promised to save no money. I've promised to save no SADI. So that way I can't be wrong. So why are we driving towards SIM for this project? Probably the primary reason is it appears to be unreasonable to not go for a SIM implementation at this stage of the product lifecycle. It's available. It appears to be the way of the future. People are sitting on this call because they perceive it as the way of the future. It's enabling me to exploit the asset data that we've collected over time in the business. It provides a variety of visualization options for the control room. That situational awareness just gets better or gets more open with multiple views of the same data. And then we perceive that it gives us a good way forward with going towards distribution power flow, FLISA, LV management, DOOMS, and various other products as we get to them. So I finished importing the last of my feeders. When I say I mean myself and the GE team behind me. Imported the last of the feeders into our network yesterday afternoon. We've started schematising the feeders. We're schematising them with a manual schematisation process. So there's a crew of cartographers out there taking the SIM imported data and bringing it in. Where this comes to play, so if you look at both of those things in an edited view, so you can see there's a lot more componentry in the SIM imported stuff, and also when you schematise it, than you would normally expect. Normally you'd just expect lines and connectors. So that's where some of the complexity comes into it. So the schematisation process itself is a jigsaw puzzle where you must redraw the picture in a schematised way, but you must use all of the components and all of the pieces that you were given previously. So there's some significant challenges in that for the cartographers. So how did we get to here? So our first place of call was our existing GIS vendor told me that they had a valid SIM adapter that would do the work, would allow me to connect my Hexagon GIS directly to POA, and we could exchange information. So early on in the piece we went through a proof of concept and we proved conclusively it wasn't going to work. So that was, it was a well-spent tens of thousands of dollars to not bury ourselves in that hole. So we went back to the drawing board. I'll just have a manually drawn network and I'll migrate to SIM at a later stage. I think a lot of the customers out there have found that migrating from a manually drawn network to SIM is quite a difficult thing, and it would be an impairment on my project budget in the order of $300,000 or $400,000, I suspect, in the end, and so that wasn't really that viable. So at that stage, we were still having conversations with GE, and they came back proposing to use Electric Office as an adapter as a middleware type of arrangement. So we've pushed ahead with that. So effectively, the geography is just as you see it there. Electric Office reads directly from my existing Oracle GIS tables. It imports stuff and ships it along to POA after a significant amount of manipulation and data cleansing. All of the data cleansing issues that David spoke about, I've seen, I've experienced, and we believe we've got means of resolving them. It's not as clean as you'd like. So, if I maybe, I'll talk back to Roberto's first or last slide that he gave us when he talked about how to plan and go about a GIS ADMS integration. We probably didn't follow his slide. Sorry to use your slide, Roberto, but it's quite informative about what I should have done. So the integration plan wasn't quite done as well as we'd like. GIS data readiness is an interesting term. At the start of this process, everyone talked about data readiness, but no one could define what it is. We've been working very hard with the Electric Office people since November last year, effectively trying to resolve our data readiness. Lots of on-the-fly cleansing, a lot of applying of data rules to it. So the integration planning was a bit poorly done. The preparation, we had to create 2 sets of asset mapping rules from our existing GIS into Electric Office and then from Electric Office into Power On. We've set up the SIM configuration. That is a significant piece of work that Malcolm Osborne from GE has undertaken and succeeded with. And we've used an ADMS symbology that was derived for a manually drawn network that provides some interesting challenges. So we've been through the piloting and loading of things, and we're now in production. So we've imported all the circuits. Like I say, I finished importing them all yesterday afternoon. We've validated them at a visual state. So every connection, every transformer, every switch has been had eyes laid on it and tried to see whether it is electrically sensible. Because certainly some of the GIS data in there that we'd drawn was not drawn by in an electrically likely manner. We've connected the fuses on the wrong side of things. We've failed to supply things. We've misnamed our switches. So switches inside RMUs come out looking like ABSs. We didn't install fuses and fuse switches. We had issues around our sectionalizers and reclosers. So all of those good fun things. If we get back to the find the right slide. So my last slide is really it's the trials and tribulations of what's gone on. Importing the data into Electric Office was quite easy. We felt very comfortable. It happened in about a month. I don't think it stressed out anyone there. The electrical connectivity, so we circuitized things. That was quite a large piece of work, getting in there. And then we started importing circuits into our network. And we'd actually gone quite a long way there before we observed that the ADMS is actually phase aware. And so we didn't have any connectivity between our points of supply, where I had inconsistent phasing in a fuse set. So you'd have a two-phase fuse heading to a 3-phase transformer, so you didn't have consistent phasing all the way through there. And that was endemic throughout my data set, where we hadn't maintained phasing continuity through things. Circuit hierarchies required some massaging just to get things into circuits. There was a pile of componentry in our GIS data set that hadn't been homed to a feeder. So they were there, they were visually in the GIS. You could follow them with your finger, but they weren't in the electronic hierarchy. Funnily enough, my SCADA people and my GIS people, although they're located about 10 metres away from each other, have never agreed on a naming convention between components. So they're quite different in naming, so we needed a standardisation process to go through that. So that was all just to get it to we could start to import data into our things. The presentation of all the data that appears in the ADMS is pre-staged in your GIS. So ADMS itself has very little presentation capability, so you need to think all the way from that first component, how it's laid out in your GIS. It's going to very much affect how it's going to appear in your geo world and your ADMS. And it's a difficult thing, particularly if you're starting one GIS separated from the actual one. So we're going through a manual schematization of the imported feeders, which is quite a labour-intensive process. There's a crew of people working on that at the moment. They're suffering from some of the decisions we've made to get to this point. So it's not a simpler process as just drawing it from the start. And certainly the symbols that we're using in our network, if we had designed them properly for a GIS integrated thing, then we would have had them set up, because their presentation, orientation, scale, zooming, declutter, all of those things are different, because the scale factors are different between your geo worlds and your schematic worlds. So there's a lot of things to be resolved going through. None of this is showstopper, but it is a lot of work and challenging. It's taking longer than expected and causing me to feel older than I felt. So if I was starting this again, I'd start with a clean GIS data set. I now have a better idea about what that means, and certainly the GE staff I've been working with now have a far greater understanding of what clean GIS data might look like. There was no clarity around that at the start. The symbology needs to be thought through a lot better than I've thought through it myself for this. And it needs to be considered right back at the SCADA import cycle of the process, because we could actually lay down some of those SCADA symbols instead of manually drawing them in the import process if we do it. And the real question at the bottom of, would I do it again? I would certainly do it again. The power of this stuff is it's awesome to be able to walk through, to see a component in a sub-transmission world and distribution world in a geographic visualization. It's the same component, so the life cycle of it's the same. You can work between those worlds, between all three worlds simultaneously for what suits the visualization you're after at the time. And I believe that's going to add some real benefit to our people when we get in production. My first slide said it was in production the 31st of July. I believe we had some technical issues yesterday and some other performance issues this week, so I suspect we might be another month later. But it is coming and it is working, and I believe it's going to live up to the sales pitch that I purchased the product on. So I think it's a future, and I would recommend going for it. I believe I've probably overspoken my time, so we'll hand back to Roberto, and he can.
Yeah, thank you, Matthew and David, for sharing your experience with our audience here today. All right, so in conclusion, today's discussion should have provided an understanding of how having a single vendor help with that end-to-end interoperability can reduce the initial implementation cost. And there are lots of steps to take, and there is a process that is becoming shared and discussed on the call here today. So I want to thank our two customer presenters for sharing their experience. And GE's end-to-end GIS and ADMS solution really builds on a deep electrical domain expertise. So the GIS electric model is validated, and the data that's coming across to the ADMS is an electrically valid model that can be brought in. But getting a GIS data set to that point can be a bit of work and may take some effort to get the data to that situation. And then once you're there, you can continue to maintain the network model over time and manage that update process throughout the life cycle of your new assets coming into the network. With our network-based GIS managing the evolution of the network model, what the future looks like from a GE perspective is creating this digital utility where we can really break down those silos that have built up over the years and start to build up an ecosystem where the data from the disparate systems can be orchestrated into what we call a utility data fabric and create a shared, consistent view of the network model across the entire enterprise. So this vision of the data fabric can be used to get further value from your geospatial network model, help do simulations of weather impacts, improve storm preparedness, outage response, and really help understand how the network would behave under those different types of load and DER growth scenarios that we are all going to be facing in the future. So getting more value from that data through advanced analytics and other additional solutions is really the broader vision that we have within GEs. And network model orchestration across your enterprise will enable you to gain the benefits of an end-to-end solution that continues to evolve towards enabling that network level optimization. So today's discussion was focused mainly on the integration between the GIS and ADMS. And if you are interested in learning more about our Smallworld Electric Office GIS, please let your GE representative know, and we can discuss that as a follow-up to this webinar. So with that, I'd like to open up the webinar for a question and answer session, and I'll hand it over to you, Robert, to moderate those questions for us.
Great, thanks, Jennifer. Yeah, we see a question coming in from Greg Baldwin. How does the DMS network patch process work in relation to updating the GIS? I.e., when does the GIS change after a DMS diagram patch is introduced?
Yeah, so within, did you want to take a stab at that?
No, you got it.
Okay, so within the workflow on the GIS.
Okay, so we've got patching available in our network. So patching goes the other way around. It comes from your GIS to your DMS, not from your DMS to your GIS. So
yeah, that's right. Yeah, so the network model changes are made in the GIS and propagated into the as a patch into the DMS. And that's all managed through the workflow of the design process on the GIS side of things. And the workflow, when that data is past certain stages in the design process and ready to be provisioned on the ADMS side, then the workflow will send that information across, and the ADMS can process that and integrate the patch into the network model from the ADMS perspective.
Yep, that sounds right. There's another question from Stephen, maybe the last one, as we're running a little bit over time. How did Energy Queensland and Top Energy import their customer data and load profile data? And Matthew, if I talk on your behalf on this one, we didn't go through the SIM import for the customer data nor load profile data. There are other utilities in the ADMS, our enterprise gateway, where we use standard XML SOAP services to import that data. And we've got predefined structures and WSDLs to facilitate that loading, as well as incremental trickle feeding updates to customer data. On that note, there's no more questions, but if you do have any other questions, please send them through via email, and we will answer them. I would like to thank Jennifer and Matthew and David for sharing the insights and experiences around the GIS and ADMS integration. I know their perseverance through data quality and alignment issues is testament to the value of this integration, and I'm sure it'll serve as encouragement for all utilities planning or thinking about integrating the GIS to the ADMS. Again, a big thank you to all the attendees for taking the time to attend today's webinar. I hope to speak to you all soon on the next webinar, and bye for now.